Okay, Sarah. Oftentimes we hear about cybersecurity, cyber safety, cyber. But what I did like about this interview is she talks about the cyber physical, as in how
Yes.
things in the cyber world impact the physical world.
Mhm.
And she goes in and discusses the intersect of both I kept thinking machine learning every time she said it, because very
Right.
deep learning is what they
Deep
call it, but it
learning.
sounds like machine learning.
Mhm.
I think it's very similar to machine learning there, and the block chain.
Yes.
And so how those things or the intersect of those
Mhm.
is the world that she works in, and looking at the safety, the security, how these things work together, and all the smart devices that we
Right.
have and we have in the world. This is going to be more and more important as we go.
Mhm.
And I just love that she was able to explain what these terms meant and kind of break them down in a way that I could understand a lot better.
I think so, and I think just with more situations for technology
Mhm.
in our everyday lives, that there's also more and more possibilities for cyber attacks, and we can cut down the time to recognize and resolve these types of attacks
Yes.
by planning for that in the very lab that Jin Wei-Kocsis uses.
So listen up to this one and follow along. Thank you.
Joining us today on Superheroes of Science, we're so pleased to welcome Jin Wei-Kocsis. Jin is an assistant professor with computer and information technology here at Purdue University. So thank you so much for joining us.
Thank you very much. Really appreciate the opportunity for sharing some of our research and education insights in our lab. So hello, everyone. And again, I'm Jin Wei-Kocsis. I'm assistant professor in computer and information technology. And I'm also the director of the research lab called the Cyber Physical Social System Design Lab. So in our lab, we kind of focusing on and developing the multidisciplinary research work in securing the cyber physical social critical infrastructures. So as we can observe in recent years, due to the advances in sensing, computing, and networking, there will be tighter and tighter correlation between the cyber components, physical systems, and human including operators and end users. So here kind of shows 3 examples. First, it is the smart energy systems. We can see there has a bigger coupling and more complex. Second is the intelligent transportation. The last one is a smart farm. So those kind of tight coupling between the cyber component, the physical systems, and the human factors dramatically improve the efficiency and the effectiveness of the operation in those critical infrastructures. However, at the same time, they also introduce some unfamiliar attack vectors and also results in the increasing vulnerability to the cyber attacks and the physical failures. There are different solutions have been provided for securing the critical infrastructures and also enhancing the resilience. Those kind of solutions definitely very effective under the certain scenario considered by the proposers, like the researchers and also engineers. However, there still remains some essential challenge for achieving this kind of resilient and secure critical infrastructures in the complex scenario nowadays. This has been demonstrated by the cyber attacks recently occurred in the Florida water plant, and also another cyber physical attacks occurred in the power system in Ukraine in 2015 and 2016. So because of that, yeah.
Just a couple of terminology things I'm curious about. I see,
Sure.
especially with the one in the Ukraine, you have that listed as a cyber physical attack. And so when you say cyber physical attack, does that mean a person was physically at that location to be able to hack into a system?
So it's kind of a, generally speaking, it is this way, but for this special case, it's kind of, they start with the cyber attacks, and then they are able to access to the system via the certain complicated identified paths. And after that, basically, actually, they eavesdrop through the eavesdropping for a long time, and then they identify the target they want to compromise at, and then they're able to hack the system through the cyber attacks, but it results in the outage in the physical systems. So they kind of the how to say the way the method is kind of through the cyber, but the target it is the physical systems.
Oh,
That's
perfect.
why from that kind of perspective, actually the first one, the attack in the Florida power plant, also we can consider as the cyber physical attacks, but because there they heavily rely on the cyber attacks part, that's why I mentioned it is the cyber attacks.
Perfect. Thank you.
Thank you. So again, this is the picture we recently took in our lab. So our lab is aimed to address those existing challenges and try to pave the way to achieve the next generation resilient cyber physical social critical infrastructures by providing the deep learning driven those intelligent solutions for securing the systems. And we developed the solution by considering different application fields, such as the deep space exploration for a NASA project, and also the drone detection, UAS detection, and also the securing the next generation energy systems with high penetration of renewable energy. So, but although we focus on different applications, but they really align with the same domain from the research perspective. It's how we're able to develop a computing and the networking and the control infrastructure. So for us be able to analyze, to detect those kind of potential stress in advance and be able to mitigate that in a timely manner. So here, because we kind of focus on really different directions, although aligned with the same under the same umbrella. So here, because of limited time, I want to focus on one. I think for me, it's very exciting area we focus on is how we are able to leverage deep learning and blockchain, which are the very emerging technology, to develop a cooperative and securing computing infrastructure in order to secure the cyber physical social critical infrastructures. So
can we define
here,
both of those two though? Because you're using some terminology here. I know blockchain I've not heard of, and deep learning I think I might know what it is, but I'm not sure. So could you explain what those two domains are?
And really quick for our audio listeners, we are looking at a graph that's a Venn diagram that's showing the intersection of deep learning and blockchain with this cooperative and secure computing.
Sure, thank you. Actually, that is exactly how me to introduce next slide. Is I kind of try to talk about the deep learning and the blockchain technology in slightly in depth individually, because I think these two terms we can hear everywhere, the best term almost, but it's not every of us, because we have from different background to know what they exactly refer to. So here I try to take this opportunity to provide some insight about really what is deep learning, what the blockchain is. So first, the deep learning. So the main idea about the deep learning, let's kind of way back from the technology term, just to try to say what we already observe in our everyday life for the applications by using deep learning. One is shown here is a self-driving car. So we know Tesla and the other self-driving cars are more and more popular nowadays. So people do not have to make the decision always by themselves. So the car be able to make the decision. How they do that? The main idea is following the deep learning applied in computer vision. So they are able, like shown here, they're able to send some computer vision and data, and then they do certain analysis. And the output is a decision making about whether you want to turn left, you want to turn right, you want to stop or continue. So this is one application we see. So another application, it is kind of more from the manufacturing and engineering perspective. Like the manufacturing and the power system nowadays is not everything rely on the operator anymore, because now we have a lot of autonomous systems. So we have the sensors, we have the autonomous mechanism. They are able to get the lifelong monitoring, and then they make the decision without always have to listen to the operator. So from these two applications, oh, I actually include two more. So one, it is the the smart house care. So we know now we have the smart watch, right? Apple Watch, and my husband has all kind of healthcare watch. So how the monitoring the kind of your heart health condition and other your exercise condition. So those ones is not that straightforward. It's not like I monitor the data, I can give you the results, because different people has a different variation. If you observe closely, you can see the results they give you is more and more accurate after you use that for a while. Why? Because they kind of leveraging this kind of deep learning model, so they are able to understanding using the deep learning model, understanding your behavior, formulate your overall the conditions, so they are able to improve their decision making about oh, you need to sleep at a certain time, now your time for you to exercise, and so on. So the last one is a smart farm, because before when we hear about the farm, we always think about this labor work, but now it's not that at all. So now there's a lot of sensors, a lot of people using drones to get the monitoring, to get the decision making in real time. So in that way, they're able to improve the productivity for the farm, which has a large scalability. So we see so many things. Let's just skip this part. This is another application, but I just quickly say this one. It is because I'm involved in NASA project. So NASA such as the NASA Glenn Center and also other NASA center, they collaborate with their partners like HP, try to bring the artificial intelligence, which is a bigger concept, include deep learning into the deep space, such as using those technology to improve their communication in deep space and also improve their efficiency in the International Space Station. So we see so many applications, but what really is deep learning? What is really artificial intelligence? So I developed two courses, one graduate level, one undergraduate level in our department, and both related to the artificial intelligence and the deep learning. At the beginning, students always think deep learning is a magic box. So whatever I throw some data inside, output will be exactly accurate decision making for me to do certain applications. But actually that is not always the case. So deep learning, although we hear that everywhere and we see so many emerging applications, but if we look at inside of that, it's just a function. So it is a process of generating a function automatically and implicitly. So that function is set the mapping between the data we are able to obtain and to the output we want to achieve. So here I give some example, just summarize again. So what is deep learning? Deep learning, it is a procedure we're able to automatically and implicitly formulate an artificial intelligence function for the given application. So here I give some example. First, image recognition. Basically, I send you some pictures without a human need to judge. You need to output what's that in the picture. So that actually is really what they try to do is they try to formulate this function to map from the image. We have German Shepherd. That's why I always use German Shepherd as an example. And then output is what is the objects in the image. So if you want to do the language translation, that is really helpful for many international students. So that it basically set the function between the certain language and the other language. So another is a speech recognition. Now we use that a lot. So especially for the smart home. So basically what they really try to do is they try to formulate a function to map from the acoustic signal to the semantic meaning. So the last one I think is for me, because my hobby is painting. I think this is super attractive for me. So basically it's called the neutral style transfer. So basically it's a select painting style of one of the the most famous painter, and then you take a regular image. So you are able to fit into these two into a function that are able to fuse the style of the painting and the content of the picture. I think it's super cool.
So would this sort of be like those applications that you can get where you can take your picture and then it shows you what you would look like as a cartoon, for example?
Exactly. That is also, so you want to find a kind of the cartoon style you like and take a picture, and you can show. Actually, we have currently our phone has this app. So basically we have the Disney princess. My daughter always took her own picture and then transfer to the princess, the Disney princess character. But it follows similar idea. What really try to do is try to find a function to fuse them appropriately to get the appropriate output. So this is so many, but again, machine learning, deep learning itself is just a function formulation. They're not a magic box. They have a lot of limitation in the practical applications. So for example, as we mentioned, so many, we didn't kind of talk about touch the input. Actually, the data, the appropriate data with appropriate annotation, means explanation or label of the data, it is one of the most precious resources for ensuring the success of the machine learning. Sometimes we always call the garbage in, garbage out, means no matter how advanced your machine learning model, deep learning model is, if you don't have the appropriate data, you cannot get appropriate output. But in many applications, we can see the appropriate data is very limited. Furthermore, the appropriate annotation of the data is even more limited, because we do a research. One time we try to collect the social media data. Student using, I think, 2 weeks, just try to label those tweets, I think 4,000 tweets. So we can see it is really, how to say, has a very time consuming and labor heavy to label those data. So again, although it is a beautiful world, we think about the future of the machine learning, but currently we have the limitation of use that. So besides the data part, we also, when we run the machine learning, it is really consume a lot of computing power, but in many applications, we have limited computing power. And also overall, what we're seeing here is the machine learning model, it is trustable. But nowadays, we observe there's a lot of different type of attacks. We call adversarial attack, be able to compromise the machine learning to mislead the decision making. At the last, in many critical infrastructure, we need to do the timely response. For example, if we know the power system has something wrong, hopefully we are able to detect that immediately, respond to that immediately in order to avoid a potential power outage. So of them, we can see it is a limit the usage of the deep learning directly. So because of that, that is the motivation of we try to leveraging the other technologies such as blockchain to work together with deep learning, be able to achieve a cooperative and secure computing, which try to compromise or mitigate the challenge we have identified in the practical world. Okay, now I'll come back. What is blockchain? We heard blockchain every day. I think we can see in news, we can see in TV. So what is really blockchain? I believe many of us, when we heard blockchain, the first thing in our mind is Bitcoin. Many students tell me, I hope, or many of my friends say, I hope I bought a Bitcoin in like 5 years ago, because if I did that, I'm rich now. So because the Bitcoin, the price is increasing, and recently slightly decreasing so dramatically. So people kind of directly connect the blockchain with Bitcoin. But what I want to say is, although blockchain, this term is the first introduced in the Bitcoin paper in 2008, but blockchain, as I mentioned here, is not equal to Bitcoin. In other words, blockchain is not equal to cryptocurrency, because Bitcoin is just one type of cryptocurrency. Now we have all kinds of coins, right? Dog coins, cat coins, and so on. So as I show here, maybe it is kind of not very clear, but I put a reference paper here. So you can click and can see that in the documents, can you adjust the size. But here try to show that besides the cryptocurrency, the blockchain have been already applied in many different applications, such as cybersecurity and the privacy and education and the health and also transportation and so on. So here I try to kind of provide understandable words to explain, because Bitcoin as a blockchain itself is based on cryptography and so on. So it's kind of complicated from mathematical explanation. Here I kind of explain that from the conceptual perspective. So the main idea here is in the blockchain platform, there's a set of transactions will stack together. And then when they stack the transactions, they have to verify the authenticity of the transaction. Who verify that? Miner. I believe many of us heard miner, this term. Miner verify that. But the miner is not really, it's someone is doing the mining physically work, labor work. So what really the miner is just some decentralized entity. So decentralized computing units. So they're able to run certain algorithm automatically in order to verify whether that the transaction has a proper authenticity. And also during the whole time, so they have to follow some rule. They cannot just randomly do some algorithm, follow some rule to do this mining properly. That the rule, that the protocol, we normally call consensus protocols. So after that, after the verified, those kind of transactions will stack together. And then through the stack, I think I actually show here how they do the stack together. So we can see that each multiple transactions will store in the individual corresponding blocks. And then those transactions will stack together through achieving the chain of blocks. Actually, from the name, we can see blockchain, chain of blocks. So how they really stack? They stack through the hash value associated with each block. The hash value is determined by the content of the transaction stored in that block. Also, the hash value of the previous block. So just imagine, so your block, you will have a hash value, kind of ID of your block. And that ID is determined by the content currently in the block and the ID of the previous block. So what is resulting? Resulting if any attacker try to manipulate any of the transaction in certain block, they will result in the ID of the whole blocks in the other blocks in the whole chain will be changed. So in that way, they dramatically increase the possibility to be detected by the outsider or by the operators in the system. So that is kind of main idea about why the blockchain can provide the transparency, also provide the security, integrity security for many different applications. So besides, so the security part, we also, for our work, we really like the decentralized part. As we mentioned, how to verify the transaction is not verified by a centralized entity. It's verified and generalized by the individual decentralized entity. So in that way, the transparency of the transactions and also the ownership of the transaction is much easier to tracking and to secure. So here, I will not emphasize in detail, but I just want to show here has really a lot of benefits we're able to achieve from this decentralization provided by the blockchain.
So it's sort of like with blockchain, and like if you're like, if we think about money, for example, instead of where I might have like one cash box where I have all my money, maybe instead I have just different jars with different amounts set up all over. So if they get to one jar, I still have all my others are protected. Is that kind of what I'm understanding?
So yeah, so I think that is another, what you mentioned actually is another thing we focus on, is rely on the blockchain, but it's a data storage technology leveraging this kind of decentralization. So basically is when that is another very well of the main application using the blockchain. So basically rather than we only have a one record of the certain, no matter money or the other digital assets.
Right.
So instead of they stored in one centralized unit, they store in decentralized nodes. So in that way, no one really can secretly change, because if you want to change one, you have to change all. So another thing is easier to track. So another thing for here is also, besides that, from relatively high level, the blockchain technology, basically, you are not able to say, I told you this transaction is verified. For example, someone and pay the Bitcoin and to the other side, and the other side send some whatever product to this side. It's those kind of transaction. It's not only verified by one person. So I say, okay, done. So in that way, if I'm the attacker, actually, I kind of work together with the part, they only want to get the money, Bitcoin, rather than want to give the product. So in that way, it's difficult to track and difficult to identify. So here it is a decentralized unit. So not only me as a decentralized entity able to verify that at the same time. So in that way, it's difficult to compromise this kind of a verification by one or two malicious attackers. But it really has a dramatic applications there, which is not only the cryptocurrency, although that is most attractive part nowadays. So here is the core part of our work. What will happen when deep learning meets Bitcoin, or I'll say Bitcoin, the deep learning meets the blockchain. So here, our own ideas, we try to leverage the security property and the decentralization capability of a blockchain, and the very powerful computing capability of deep learning together achieve a cooperative and secure computing, which aimed to address the challenge of the requirement of the high computing power, and also the lack of the data, and the potentially concern of privacy. So this figure, it is kind of fancy, but it is very straightforward. So the main idea here is, imagine we have a lot of computing nodes. Maybe some is just Raspberry Pi, and some is a regular small digital devices, has a very limiting computing power. So in that way, rely on one devices. For example, one Raspberry Pi is difficult to do very computing demanded applications. So in that way, we try to think, how about we kind of set up some secure and trustworthy collaboration between the different those kind of computing devices, and then they work together in order to achieve certain application which originally is computing demanded. So those kind of computing nodes be able to join those kind of collaboration, but play with as one of the three roles. It can play as an application initiator, it can play as a computing contributor, or it can play as a verification contributor. So if it is application initiator, from the name we can say basically initiate application. Basically, I will announce certain application I want to help from the other computing nodes. And then I will specify the objective and also the constraints of my application. But I don't want anyone try to change that secretly. That's why I will specify that, announce that, while writing that into the smart contract, which is one of the core components in blockchain technology. So in that way, everyone who joins this platform can see directly because it's decentralized, and also no one can change that. And then if I'm the computing contributor, I will say, oh, I want to join the job, and then I want to help the application initiator. Then I'm able to access that smart contract characterizing what the task is, and using my own data or using the data shared by the application initiator to generate some local learning model, deep learning model. And then after I generate, because we have to avoid some potential malicious entities. So it's this kind of a model is not directly used by the application initiator. So what I do is, if I'm an application initiator, I will announce in this platform. So after I announced, some verification contributor, which I played as a third role, will kick in to verify whether my model is good has a good quality or bad quality. And then there will be multiple verification contributor will be selected. They have the majority votes on my learning model has a good quality. Then I will have a transaction between myself and the application initiator. Basically, I will share the model to the application initiator. I can get a certain financial or other compensation from the application initiator. So I think the whole thing is a kind of if we think everyday life, we potentially have this kind of activity. But here, through the blockchain, everything, every collaboration will be verified and also will be secured. And another side is this encourage the different computing nodes where the owner of the computing nodes will contribute their computing power to the application. And we have published our work in the transaction and we continue to working on that. And this is kind of a test bed, the picture of a test bed in our lab. So we can see here, I'm not sure whether it's very clear. So here we have a multiple, this kind of stack is a multiple Raspberry Pi. It basically has a very limited computing power. Here it is also, we call the embedded GPU. Basically has a relatively higher computing power compared with Raspberry Pi, but also very limited. We try to use that to emulate the real world scenario that there has a different type of computing devices with a different level of computing power. If we imagine this, we do not have to be Raspberry Pi, can be our cell phone and can be your smartwatch and so on. So as that has a certain computing power, has a certain storage capability, that will be good enough. And in order to make sure they're able to communicate properly, we have the software-defined radio to help to set up the communication. But because that is another direction of the research, here we now focus on that part. And here it is to show how the decentralized computing nodes collaborate. I will show a case study later. And here is to try to give the signal how the communication nodes will set up the reliable communications. And we kind of evaluate in different, just give some example. This one is a large power system. I'm not sure whether we can imagine what is the large power system is. It's including the power line we see, and also including the distribution system. It is connect to the users, to our residential users. But potentially, we emulate situation. There is 44 different locations potentially has a fault. Actually, only one of the 44 locations has a fault. And we want to quickly identify where the fault is and what the fault is in order for us to have the timely response. And we're using our work and to the analysis, and we can see the overall we can achieve about 90% accuracy for detecting the location, one of the 44 locations, and identify the type of the location. So here is another interesting application. Basically, we try to identify and detect and recognize. The detect means detect whether there is a drone or not. And recognition is identify the type of drone. Because this application is because nowadays the drone has a lot of application in different fields, in farm, in power system manufacturing. At the same time, it has introduced a lot of threats because we don't want some random drone fly near the airport. They need to follow their regulation, right? Otherwise, they will have big issues. We heard in Europe, some of the country is some of the news I recently heard just because of the drones. So they have to close their airport for hours, delay a lot of flights. So all of them is make we think there's no free lunch. When you get benefits, you always prepare for potential disadvantage part to prevent. So here is just to try to detect potential threat from the drones and prepare for that situation. So here we have the drones, and we also generate the RF signal, the radio frequency signal corresponding to drones. From here, I'm not sure whether clear. You can see actually associated with the different drones, our result in pattern of the RF signal, which called SCF signal, is follow different unique patterns. So the idea here is we are able to collect the RF signal, generate SCF pattern, and using that pattern to detect whether there is a zone or not, and if there is, what zone it is. So here the reference means there's nothing there. It's just the white noise. So here I just try to show, I think it's kind of a small, but here is the simulation for that case study, detect the zones. So here is, let me stop first. I just try to explain what here is. In this case study, we have one application initiator. If you recall, that is kind of announced task. We have a multiple computing contributor, but because of the limitation of the screen, we show 3 of the computing contributors. If you recall, what that is, try to help the application initiator to train their local model at their local situation. And here is a 3 verification contributor, which is aimed to verify if they achieve some model, whether that model is good enough to be used by the application initiator. So if we start, we can see here it began to publish a task. After publish task, we can see those computing contributor will be online and then we start training. So, and it take a little bit while. Okay, so here we can see the complete training and then they began to publish, means tell and finish. After they achieve that finish, we can see this verification contributor start to work to verify the individual claimed model. So it again still take a little bit while. So after that, so we can see. Sorry, so take a we just take a screen record. So they identify, they verify the computing contributors model individually, and then they will get the conclusions. Okay, so here we can see the get conclusion. This is the conclusion on what model is verified by them. So after that, they will tell the application initiator. So then they will collect the votes. So basically here they will say the first model get by the first computing contributor gets 3 votes, other 3 votes, and the other 2 votes. So through that, they will decide whether this application initiator will use that learning model. If they decide to use, the transaction between the associated application initiator and the associated learning model will set up this transaction. This will get money or get other type of compensation. This will achieve the model. So at the last, here, I just want to say is there is a lot of other potentials we have not explored to see what is the benefit we can get by integrating the deep learning technology and the blockchain technology seamlessly. So here it gives them examples, the application we can get. For example, we can achieve the intelligent satellite constellation. That is actually currently we are working on, and also have the connected civil aircrafts. Because the individual aircraft have limited computing power, but if they work together, they can achieve the more appropriate situational awareness. And also they have the connected smart vehicles, connected the healthcare, and the smart homes, and so on. So overall, we believe this kind of integration can result in next generation decentralized, cooperative, and secure computing paradigm. And one of the application paradigm is to improve the security of the critical infrastructure. And for this work, I can see they provide kind of link into the different career opportunities. For example, people, if the students be able to have the hands-on opportunity there, enhance their capability, they can prepare, it can prepare them for the artificial intelligence researcher, the software engineer, the blockchain developer, and the blockchain user interface developer, and also security analyst, and also security architect. So that is the main idea and the main introduction from me for our research.
Well, it makes a lot of sense that as things, all of our devices are getting smarter and we have just more incorporation of technology really into every aspect of our life, that we would need more advanced ways of securing all of that information. So it's nice to hear an explanation of how that, those security measures are being developed in labs like yours.
Yeah.
Thank you.
There's so many smart devices we're getting now.
Right.
Our houses are connected. It's like their own little blockchain section within a house, and it's really cool. And I guess I never thought about it, but definitely need to make sure we do have that security going back and forth between devices like that. And so yeah, this is really neat.
Very informative.
We think about the cyber security and the cyber connections, but a lot of times we don't think about the cyber physical. And so how is that actually impacting physically people,
right,
and stuff?
Yeah.
If you hack my smart fridge, then you might be able to spoil my food. And it's even on a small level like that. So this is definitely, I can foresee a lot of application more and more in the future for this area.
Thank you.
Yes, thank you so much for your time
Yes,
today and explain, going through the differences between, and defining deep learning and blockchain for us, and really explaining all of the ways that your lab is looking into these issues.
Yes, thank you.
Thank you very much for the opportunity.
Perfect.